Alright guys, welcome to the lesson on calculating density. This is a really important concept and topic that we study in chemistry, and it's something that is really useful for a lot of the other things in the real world and in chemistry classes. So this is an important skill to know how to do, being able to calculate density. So first off, the formula for density, if you remember, is D equals m over v, mass over volume. So D density equals m mass over v volume. So mass over volume. Yeah, so density equals mass over volume. And generally how we report density, the units would be mass in grams, and then volume is in centimeters cubed. So we'd be density is mass in grams over volume in centimeters cubed. So we might get something like 5.4 grams per centimeters cubed is how we would write that. That would be the units for density. So in our example here, we have a favorite pet turtle. The turtle has a volume of 8 centimeters cubed and a mass of 1 times 10 to the 5th milligrams. We want to calculate the density of the turtle and express your answer, and there we are, grams per centimeter cubed, and in scientific notation. So we want to make sure we write our answer in scientific notation. Now this wouldn't be, since it's a turtle, he has like skin and a shell, so this would be like the average density of the turtle. So let's see how we start here. Let's write down what we know. So if we look in our equation here, we want to find density. We have volume, we have mass, but notice the units are not the same. This mass is in milligrams, we need it in grams, and then the volume, luckily, we have already in the same units. So let's write this out here. So density is going to equal our mass. Oh, that's not the mass. It's going to equal our mass, which is 1 times 10 to the 5th over our volume, which is 8 centimeters cubed, and then here we have milligrams. Now when you're going between units, when you're doing unit conversions like this, a good way to do it is to cancel out the units. And so to do that, the units have to be on opposite sides of the equation, not of the equation. One has to be in the numerator, one has to be in the denominator. So if we have here, on this fraction here, we have milligrams in the top. To cancel it out, it has to be on the bottom of a fraction. And so we can do that by using a conversion like this. We want milligrams on the bottom, and we want to get it to grams. Grams is on top. So let's do 1 gram is equal to 1,000 milligrams. And that's just a standard conversion. That's just a normal metric conversion. That's always the case. 1 gram is always equal to 1,000 milligrams. And now notice, since we have milligrams on the top here, and we're multiplying, and we have milligrams on the bottom here, what we can do is cross out the milligrams. So those units cancel. Now look what we're left with. We still have centimeters cubed on the bottom. We didn't do anything with that. That stays the same. And now look, we have grams on the top. And then if we go over here to what we need for density and what's asked for in the equation, we need grams on the top and we need centimeters cubed on the bottom. So it looks like we're good to go. Now to get our answer, you just multiply across the top, multiply across the bottom, and then divide. So 1 times 10 to the fifth times 1 is 1 times 10 to the fifth still. Multiply across the bottom. 8 times 1,000 is 8,000. Let's see if that 8 shows up here. There we go. And now we just divide, so 1 times 10 to the fifth divided by 8,000 ends up equaling 12.5. And then we have our units still, and I didn't leave myself very much room, but we still have our units, right? We still have grams on top, so I should put that here, and we still have centimeters cubed on the bottom. And so we have grams over centimeters cubed. And now when you're done with a problem like this, always go back and check to see if you have the answer like you're supposed to. And it looks like they want it in scientific notation. This is not scientific notation, right? We need to change this answer into an answer that looks like this. So how do we do that? Let's go down here, 12.5. And then to do that, generally in scientific notation, the number this number here, the one that's being multiplied by 10 to some power, has to be less than 10. So it would be 9.99 or below. And so here we can just, what you do, you move the decimal one spot to the left here to get it under 10, and then we have 1.25 times 10 to the, now we need to figure out what power that it's to, right? We know we moved the decimal, remember we moved the decimal to the left. So to change this back into 12.5, we'd have to move the decimal back to the right. So we want this to be positive, and we move one spot, we'd have to move one spot to the right to get our answer back to 12.5. So 1. And then we don't forget our units, grams per centimeter cubed. And there we go.